Good morning, children. This is the maths activities for Monday the 4th of May. First thing is mental maths, reading 3-digit numbers, prove it cards, and I can solve 4-digit, take away 4-digit in columns. So we can start off with the subtraction column work. So here we've got some sums. If you can put them into columns. There are some of them where you need to borrow and exchange. So have a good look at the numbers. Some of them you can do in your head. Some of them you may need, well, you should really write them down in columns. And then we've got some prove it cards. So think and talk about these digits. The different 3-digit numbers are more than 350 that can be made using just 3 of these 4 cards. So which 3-digit numbers can you make that are going to be more than 350? So have a good look at your digits, put them in the right order, hundreds, tens and units, and then see if you can produce 3 different numbers. And for this one, you've got a number line from 0 to 10,000. We've got a place there. Can you put 4 numbers that would belong in that gap? Okay, so very carefully count the scale and then see if you can work that one out. Okay, for the main activity for Monday, we're looking at factors again. We covered this in last term, so we're going to go over it again. To recognise and use factors. Steps to success: match factors to multiples, find factor pairs of numbers up to 40, find factor pairs of numbers over 40, explore factors of numbers. So we've got a learning reminder here. Factors of numbers up to 40. So we try 16. 1 times 16, so this is one array, one row of 16 numbers. Then 2 times 8, 2 rows of 8. 2 times 8 makes 16. 4 times 4, 4 lots of 4. 4 times 4 is 16. So 16 has 5 factors, 1, 2, 4, 8, and 16. Because 4 times 4 is repeated, we only use 4 once, so it's got 5 factors, 16. 4 is paired with itself, so we don't have to count it twice. Next one is, how many factors does 21 have? Is it more than 5, which is for 16? It's a bigger number, but does that make a difference? So the possible different arrays for 21 counters, we've got 3 rows of 7. 3 times 7 makes 21. 1 times 21. And they are the only arrays that you can make. So 21 has just 4 factors. 1, 21, 3, and 7. If you can notice that the number 21 and 16 itself is a factor. So 21 is a factor of 21 and 16 is a factor of 16. It's like that for all the numbers. And also 1. When you times a number by itself, it stays the same. Then we've got some factor pairs. If you can look at this example. So the factor pairs for 20, 4 times 5, 10 times 2, and 1 times 20. So 20 has 6 factors. You can do the same for 10, 16, what's this one? Look carefully, put the number on the top, and then you can do some rainbow factor pairs for 18 and 32. That leads you nicely on to the practice sheet. This is the mild one. You've got section A, section B. Match each number to its factor, add the number itself to the list of factors. So, for example, 15 has 15 as a factor, so 15 must be added to 1, 3, and 5. So this is the one, so you link up 15 to 3, 1, 5, and then you can add 15. So if you look at 15, Start off with these 1 times 15 makes 15, and 3 times 5 make 15. And there is no more factors that make 15. So 15 has 4 factors. If you're really good on them, those pieces of work, do the investigation, factor facts. So you can follow these instructions. And then just to really get your head around factors, we've got some quick fire questions. Writing down what are the factors of 68. So larger numbers, some smaller, but most of them larger. So be careful, try to cover all factors of those numbers. Good luck.